Good afternoon, everyone. I introduced myself previously. My name is Mike McConnell. I work for Horrocks Engineers. We're out of Meridian, Idaho. I'm a professional wetland scientist. I've been in the industry for about 16 years on and off. I've lived in Idaho all my life, and I'm quite proud of that. I'm joined today with my colleague, Tim Sickles, with Rio Applied Science and Engineering, and our wonderful landowner, Mr. Oberdorf. This is Phil Oberdorf. He's also a longtime Idaho resident and I believe fourth generation farmer.
Yep, that'd be correct.
Generation farmer. We also have Phil's father in the room, which I'm excited to see. And we're going to discuss a potential project in the upper watershed here, up along Big Creek and Little Creek at the old Raney Ranch. Guys, if you want to say anything about yourself, or you want me to just roll with it?
I'm just a stream restoration engineer. So other than that.
This is our first year in this Meadows Valley. We have ran cattle. I started running cattle when I was about 13 or 14 years old. Our family is historically not a cattle ranching family. We're more of a hop farming and onion farming family. But I took a liking to the cattle when I was young and kind of built up my herd from about 10 cows, and we're up to about 1,000 mother cows now. And the base of our herd runs down in Jordan Valley, Oregon. And so having the opportunity to be able to buy this ranch and increase my cow herd has been a big deal. And our first year has been a learning curve, but I think that ranch has a lot of potential to be a very productive place. So that's kind of the background of how I got here and how we were able to purchase the Raney Ranch.
That's perfect segue. The background how I got here, I was lucky enough to meet the Oberdorf family about 10 years ago, about that long ago now.
Yeah.
And I was a young guy working at Tamarack Resort and being a ski bum at the time and trying to make my my life in the world and find my niche. And I was introduced to Greg Oberdorf, and he had an idea about some property that he owned. And he was interested in learning more about resource restoration and what could be done to right the wrongs of past land management decisions. And so we ended up actually doing some aquatic resource restoration work on a piece of property in Valley County, where over the course of about a month, we planted about 3,000 live willow cuttings and a bunch of aspens and did some revegetation work along some degraded streams. Since then, I've been involved with both of the boys, Brock and Phil, and we, have always had these great conversations about what could be done and what the appropriate things to do as land managers are. And fast forward about 8 years, and the Raney Ranch comes up for sale. These guys are very focused on kind of the ecocentric land use aspect, right? And what I mean by that is it doesn't always have to just be for, farming row crop or, growing fatty cows, but, there's something to value about having cold water in the creeks and having wild fish that live there. And as land managers, they have the opportunity as private landowners to be able to do a lot more than some of us have been able to do while working with like public land administrators and things like that. So we have an idea. It's a vision. It's not a project. We are trying to gather information, and we're going to build on the information we learn along this data gathering adventure to try to do right by previous land management decisions and improve water quality along Big Creek and Little Creek. And right now we're calling this project the Raney Ranch Water Conservation and Aquatic Resource Restoration Project. Next slide. The next slide is introductions. And you guys have met my colleagues here, but the background behind this is that we were able enough, or we're lucky enough to be invited to this presentation by our friends at the Nez Perce tribe. And so Wes Keller, like you guys know, as you've sat through these Watershed Coalition meetings, is some leadership from the Nez Perce tribe. He's based out of McConnell, Idaho. Wes is here tonight with us, or today with us. Yep. And also we have some of his colleagues as well, Joanna and Miss Smith. Miller, Keisha Miller. I'm sorry, my apologies. Not too long ago, we all went out to the Raney Ranch and we took a ride around to look at the incredible opportunity that there is there. I don't have any photos because we're so like enamored with the possibilities of what could happen out there. But let me just summarize in saying that Big and Little Creek look like this. And there's totally incised channels that have been scoured to the bedrock by previous floods in '96, I believe. And through all the years of cattle ranching, there's not a whole lot of riparian vegetation left over anymore. And so there's not a whole lot of shade. There's not a whole lot of channel diversity. There's some very, impaired conditions out there that at that section of, or that segment of the watershed is adding to the impairment that we have now that we see in the watershed, which primarily is due to, heat from no shade over the water and, the influx of nutrients because there is no riparian corridor to filter those from the upland uses. And overall kind of deterioration of the functionality of the floodplain that leads to a myriad of different problems within an ecosystem like that, an aquatic ecosystem. So the purpose of this slide is to just reiterate the fact that this is a vision right now, and we know there is a long road ahead. To capitalize on my farmer friends here, this is a long road to hoe, and I want to reiterate that this is just an idea. This is a project, and we're in the concept phase of defining what those goals and opportunities are that are going to lead us towards implementing a project on the ground. In this slide, you can see the Raney Ranch project, or sorry, the property. In the red line, that is the general project boundary or the property boundary. Now, this is me, clicking these in and trying to find the cornerstones of where these parcels are, and it's pretty tight, but I understand it's probably a little bit hard to see for a lot of people too. To provide a little bit of proximity awareness here, this is all. This is all north of south of Highway 55, southwest of New Meadows, south of Old Meadows. It's at sort of like the mid segment of the Big and Little Creek watershed. On the map behind me, you can see there are a number of different colored lines. The light blue line is the North Side Canal. This is an old canal that was cut in, and it derives water from Goose and Brundage reservoirs.
Yep.
And it provides a significant amount of water to not only the Raney Ranch, but also other water users in the vicinity.
Then I like to say, Dean and Cal, if you guys see any issues with what we're talking about, just, you guys know a lot more about this, how this place waters than we do. So, yes.
The north side canal?
Well, it's called the south end.
The south side, the south end canal.
Yes.
The south end canal.
Yes.
South end.
Yes.
South end ditch.
Yeah, and so the south end ditch, from my understanding, supplies water to Cal Lowe, supplies water to Dean Dryden, Dana Purdy, and I don't know who else it provides water. The Herons, maybe?
No.
Okay.
No.
Yeah.
That's not for them. There's several others. Walkers. Mickey's involved in it.
Okay.
And there's several others, the smaller places. Yeah.
This illuminates how much we need to know and learn about this project, right? And so it's an idea, it's a concept. We've got a long ways to go. The different colors on there, you'll see there's an upper diversion ditch. It's also in that light blue. That comes off of a diversion of Big Creek. And you'll see two dark blue lines. The one further north is Little Creek. The one further to the, I guess, southwest is Big Creek. And the one that's in green is called Middle Creek. I believe Middle Creek's kind of like a colloquial name. It's not really the name of the creek, but it could quite likely be the historic channel of Big Creek. So next slide. So this kind of gives you an overview of the size of the property. It's about 1,600 acres, 1,400 acres.
I think about 17.
It's about 1,700 acres. So quite a lot of land mass, quite a lot of irrigated agricultural. So with any big project like this that comes along, there's a lot of important steps that have to be taken before you can actually like implement an idea on the field. And the first thing we have to define is the purpose and need. And I'm going to read this right off of here. The purpose of the proposed project is to improve natural stream flow in the upper tributaries of the Little Salmon River through implementation of water conservation and aquatic resource restoration strategies. So the proposed project is needed to improve water quality in Little Salmon watershed, to increase in-stream flow, reduce stream temperatures, reestablish aquatic continuity, revitalize riparian and wetland functionality, and provide high-quality habitat for native resident aquatic species, as well as potential future foreseeable runs of anadromous fishes. Next slide. As we go through this, if you guys have questions, I'm eager to answer those, but I'm going to rattle through this pretty fast so we don't take a whole lot of time. So, keep your questions in mind. There's going to be a slide at the end, and we're going to open it up for all of those. And I hope that our moderators are going to take some notes so we can capture all of that. And it'll be part of our data discovery process. So early on, we're going to develop a range of goals and objectives for which we must meet to identify how we're going to implement this project on the ground. We've learned from our strategic planning sessions that putting some structure around our perceived end goal is going to allow us to make a concerted effort. And that'll be the appropriate first steps in identifying practical and attainable goals. So next slide. We know that it's going to be a phased approach. We can't just say, we're going to do this big project and improve water quality and improve how the Raney Ranch operates. We know that it's going to be like how you eat an elephant, right? It's going to be one bite at a time. You can't eat it all in one sitting. And so we're going to take a phased approach. And one of the first phases of this is going to be identifying funding for the project. Now, I know there's a lot of options of trying to find funding, and there's means of doing so that range from private to not-for-profit to federal grants and state grants and things like that. And we're open to a wide range of funding options. Right now, our most significant potential contributor is via the Nez Perce tribes. They are strategically available to identify and to obligate funds from a lot of different resources or grantees that are not normally available to, like privateers and things like that. So we have found the Nez Perce tribe to be a very eager our participant and team member in this process. And we're going to lean on them to help us identify and procure funding as we go through the different phases of the project. So one of those first is to find what funding opportunities are actually available and try to focus our ideas of how we phase the work around what's available and how we implement these goals and objectives on the ground. Next slide. We understand it's probably going to come through multiple grants. We're not going to do it all at once. We don't expect to get one big grant allocation and do a restoration project on the ground. So we're going to try to take different chunks of different monies and allocate those based on what we see as the best goals to obtain our objectives. And I'll get into those in a second. The first thing that we have to do is gain a better understanding of what we have on the ground. And that's through a baseline site assessment. And a baseline site assessment, and I know is kind of like this, sort of a top-down term, but what it is a means of identifying existing conditions of the property and the socio-environmental climate of the region. Ah, what a buzzword. You guys hear these things from time to time, right? Like socio-environmental climate. Okay, what that really means is we know that there are stakeholders in this area that have long-standing traditions, and they also provide a lot of contribution to the community. That's the social aspect of this region. And it plays a big part in how we implement projects on the ground. We have downstream water users. It's very important that we maintain their water in a way that they, don't feel like they're being left out, or that, we provide, or we like implement something that's going to, be risky for their ongoing operation as it is now. We don't want them to change what they're doing based on what we do upstream. So it's important for us to understand those things and gain trust through the community, so we don't just, get run out of the place with 12 gauge shotguns. The environmental climate is also something to consider. And that's what we see around us, and the long-term sorts of trends in the environment, and dare I say the climate. Not a big climate change advocate, but it's important to realize that that stuff is happening. And we got to like understand that. Not only that, but the effects of wildfire, the effects of potential water users upstream, and other practices like forest management and rangeland management. They're going to affect the environment. And so that's the environmental climate of the region. So aspects of the baseline site assessment would include, but are not limited to, all of these things, right? But it's important, and I'll run through a few of them quickly, but the data gap analysis is our means of finding out what we don't know. There's a lot of stuff that we'll learn as we go through the process. And that's going to be really tied towards the fatal flaw analysis. And a fatal flaw analysis is finding those aspects of the project that are like going to kill it right off the bat. I think a lot of that probably has to do with how we procure our funding. Some of the grants are very specific in how they are implemented in the field. And so there's, grants that say, it's very specific to agricultural practices or water resource conservation. And so we're going to run through what our potential funding opportunities are and other aspects of the project that are like dead ringers, going to kill the project right off the bat, and avoid those, right? A water budget is going to be super important. This is where we're going to learn all about the water rights in the area. This is where we're going to learn about what it's going to result in when we do an improvement to the irrigation infrastructure on a piece of property, what the result of a riparian restoration project will be, and how that will be either realized through monetary benefit or an environmental benefit, or even that socioeconomic benefit. It's important to have agency coordination. There's a lot of people that are going to be involved in a project like this. And, I could spit out the agency alphabet, right? But it's going to be, federal and state cooperative agencies that are going to allow us to implement a restoration project in an aquatic resource like this. There's also an aspect of the historic attributes of the property up here. We understand that, there's been a long-standing tradition of ranching in the area, and that there's also some probably significant occupation of the area by indigenous peoples before us. Those are important aspects that we're going to have to identify if we want to do restoration projects that result in permitting through the Corps of Engineers. That's a federal hook. That's what we call the federal hook. And if we do that, then we're going to also have to involve the state historic properties, the preservation office, and they're going to tell us more about the historic context of the area, such that we take that into account when we do the project. Public outreach is huge. It's what we're doing right now, right? This is the first step of implementing something like this, is we want to gain public support from this. And that's going to be something that'll be ongoing through the whole phase of the whole process of the whole project. And environmental constraints. So far, I've done some baseline assess of my own, and to identify any fatal flaw environmental constraints, endangered species, critical habitats, things like that are kind of a really tough hurdle to be able to get across. We'll have to really detail into those. That also has to do with the aquatic resources. And like I said, the historic aspect of it as well. We're going to try to identify all of those through, data discovery and a detailed recordation of what we find through that. The water rights assessment, I think I kind of touched on that with the water budget. Super important to understand all of those things. We have a lot of great technology at our hands, especially coming from a civil engineering firm. We have experienced and expert land surveyors. We usually are now utilizing aerial imagery as well. which really gives us an opportunity to provide kind of the before and after glimpse of how a project progresses. And so that's something that we'll certainly endeavor in a baseline assessment. Permitting compliance with the agency alphabet soup. There's a bunch of them. Fortunately for the Oberdorf family, I know all of those guys and the process that it takes to get through all that. Easements and encumbrances are super important. The ditch that comes through and access to different portions of the irrigation infrastructure. There's likely easements out there that we don't understand. And we'll have to do baseline assessment to understand those better. The aquatic resource delineation, the cultural and historic resources, water quality assessment, a lot of that information is already available. And the geotechnical survey is going to allow us to know what's below the ground, kind of gives us an idea of what we can do on the ground, what the soil components are, where the bedrock is, you know, and even down to the aspect of borrow opportunities for substrate for doing some stream restoration work. You guys tired of hearing from me yet? We're about halfway through. We have to conceptualize this project before we can get anywhere. And I think that a lot of the different steps of project conceptualization can take place concurrently at the same time. And so we've already begun this process, right? It starts with an idea. We just boil it down from there. And so, you know, these are the nuts and bolts, and they're crucial elements to determine the means and methods for attaining those project goals and objectives that we're also poised to start developing. So a project schedule is huge, right? We need to know when this is going to be implemented. Cost and budget is something that we'll have to establish before we can really start facilitating any funding. And the accounting of where all those monies go is super important so we can maintain a good relationship with our grantees. The irrigation infrastructure and design and construction strategy is going to be huge for us to understand what we can and can't do. And Phil, I'm going to come to you on this in just a minute. And stream channel restoration enhancement plan. This is something that's like a solid document that we're going to use. It'll be a growing and maturing document as the process goes on and as we learn what works on the landscape through the different phases of concept or plan implementation. I'm going to come to you on that in a minute too. The aquatic resource restoration enhancement plan would mirror the stream restoration plan. That'll be my job. I'm the wetland scientist, and that's kind of my purvey. I'm going to be looking into the riparian resources upstream on reference sections and downstream to see what we can work with, what works, what doesn't, where we're at currently. An adaptive management plan and monitoring will be a huge part of making sure that these different project strategies are actually working. And then the development of a public involvement plan. Again, it's super important that we involve the public, because if we don't, we're going to create animosity and we're not going to learn as much as we can. And we know that we will lose that perception and that knowledge and that education potential from the public if we don't have an involvement plan that brings together, you know, a lot of different aspects of the people who know this place better than we do. So I want to lead over to Phil here and talk a little bit about the irrigation infrastructure design and construction strategy. We tossed around a lot of different ideas about what could be done to improve irrigation infrastructure at the Raney Ranch, and it's endless, right? But I think we've focused down on a few different options, and Phil's going to talk to that a little bit.
Do you have the map of the?
No, we don't have that. No.
So what we've talked about is creating an irrigation system designed around pivot irrigation. And our goal was to bring our water in out of Goose Creek and run it down to a central location to take out to the pivots, because we have enough gravity, or we have enough elevation to be able to pressurize our pivots off this irrigation system. So that was kind of our goal. And our goal was with the pivots was 100% coverage of the land that is irrigated right now. And it would not be 100% covered with the pivots. It would be probably 70% covered by pivot and 30% covered by big in guns that are stationary. And it would all be a gravity fed system is what our plan was. And we're also wanting to, as I know other users come off of our same ditch system that we're using. So what we'd like to do is we'd like to put a large enough pipe in so other people can tie in to our irrigation system that's pressurized. That's kind of our goal.
There's a lot of opportunities to do other sorts of like mix and match strategies out there as far as the irrigation infrastructure. And we see pivots as being probably one of the most, the best means of conserving water out there. And there's a lot of science and data behind that. Our colleagues at the NRCS have offered to do a water budget for us to give us an idea of what that conservation of water would be, like the difference between doing flood irrigation and the difference between doing downward sprinklers and in-guns. So there's information out there available and more to come too based on that. Tim Sickles is a stream restoration engineer. I will admit he has not been on site. He's only heard about it from me. And so I know I'm kind of throwing you to the wolves, Tim, here, but he's a professional in his industry, and he can tell you a little bit more about what the process would be like for doing a stream restoration project out there.
Yeah, so speaking from a very high level, as we would, even if I had seen the site, I'd probably be telling you the same things right now. The first thing we need to do is evaluate, the existing stream conditions, understand, our habitat, what our lack of habitat is right now for fish and for our riparian corridor. But then ultimately developing a stream restoration plan that accommodates the needs of the property from, if we need to manage exclusions for cattle or crossings for cattle, but also, considering our aquatic species, especially wild fish. And typically the means of providing more habitat is increasing channel complexity and diversity by increasing the sinuosity or the windiness of the channel, increasing pool frequency, riffle frequency, and we can do all these things in combination with the irrigation design. We can provide grade controls that force the water to, through means of riffle, natural grade controls to back up water if we need to provide irrigation diversion. So that can all be considered within. The other thing, we talk a lot about stream temperature, and we can look at, once we have geotechnical investigation done, we can look at groundwater exchange with the stream and also look at providing better vegetation to shade the stream. So obviously that's a very high level, but as we progress and better understand the project, we'll develop a more detailed stream restoration design.
So like I said before, we know that we have to take a phased approach at this. There's no way we could implement one big project on the ground. To kind of break it up right now, we're thinking irrigation infrastructure, big portion of this. The stream and riparian restoration aspect of it is another big portion of this. And perpetuating the continued usage of this land for ranching, I think, is also a very important aspect of this. We're proponents of land use for the production of land and livestock. So we don't want to change that. We want to make sure that that is carried on into the future. So next slide. So first thing we'd want to investigate, I think, is a lot of some of the power supply options out there. And that could come from either installing new services or even some other options that could potentially come from some technological advancements as well. I've been tossing around different ideas, and one of which I think is probably pretty applicable to the project, since we have such a large gradient and pressure, is small scale hydro. There's some really great technology out there for turning turning turbines to produce, a very renewable source of electricity. And that could not only power pivots where we need it, it could power the Raney Ranch, and it could also provide power to the community as well. The mainline pipe installation would be interesting. The easements and encumbrances that are around changing water rights or water diversions and the points of diversions and things like that are fairly significant, and we'll need to understand that more before we can actually construct that mainline pipe. And then like Phil touched on previously was the irrigation system improvements and installation. And so that would be like one of our first implementation phases is to start working on that infrastructure. And that goes along with the decommissioning of old roads and unneeded irrigation infrastructure, if that's the route that we decide to go down. Next slide. The aquatic restoration enhancement. You know, if it's deemed the right direction to take, it would be the removal of flood irrigation infrastructure. Before I touched on that we need to improve the continuity of the stream channels. And that's important for nutrient exchange and also the potential for, you know, fish passage to do their work as fish. They have to migrate and to be able to spawn in different places along the streams. Materials handling and stockpiling. I bring this up because it's very interesting. After the floods, it really moved a lot of material down the stream channels, and it piled up a lot of big areas of cobble and other material that could be used. We want to pull all that material out of where it's not supposed to be and hopefully bring it back up to create the gradient that Tim was discussing. The construction of the stream channel in the floodplain is going to be a significant undertaking, and that's going to be something that takes a lot of time and some sharp pencils to make sure it's done right. One of the big reasons we have asked Tim to come along is because, you know, we've seen what happens after a high flood event, and we want to make sure that any of the work that we implement in the field doesn't get blown out again. And not only because we don't want to waste the time and materials that we put in to doing a stream restoration project, we don't want to put any risk on anybody that's downstream in these systems to, you know, potentially maybe wipe out their irrigation infrastructure or something like that. We want to make sure it's buttoned up and dialed in tight. Installation of livestock facilities is going to be huge too. We want to be able to, convey livestock from different pastures and make sure that they, you know, can cross the creek and don't murky it up. Off-site watering is another option that we'll have to look into. Exclusionary fencing is huge, right? We want to broaden the riparian corridor so we provide a much greater opportunity for floodplain interaction. What that means is that the groundwater would seep out further and there would be more evapotranspiration. There'd be more decomposition of vegetation that would then lead to a better nutrient deposition in the soil. All of that stuff is a big working system together. And so by putting riparian exclusion fencing in there, we can engender a larger, wider breadth of riparian vegetation that will also incorporate a larger floodplain system and side channels and things like that. And then there's also the terrestrial components of it as well. You know, when you build wetlands, it affects everything. It goes into the terrestrial, which is like the upland habitat, right? Like the out of the water habitat. And we know that we're going to provide habitat for a lot of different species by doing so. Deer and elk are some of the, you know, the biggest ones that we think of, and that they're what a lot of people consider like a charismatic megafauna. But what we don't think about typically, and what's coming up to be a very hot button ticket, is our pollinators, our bees and our butterflies and things like that. And you know that they've got some negative connotation, right? Like I've heard it before, bees and butterflies, right? But these things are pretty important. If we want farms to produce food, we have to have our pollinators. And so it's becoming more and more of an issue to provide that sort of habitat. And that's a component of this project that will be very benefited from increasing the riparian corridor, and that we'll have a lot better habitat for our insects and some of the primary decomposers as well. Next slide. The monitoring aspect of it is sort of twofold. There's some other funding opportunities out there that could be realized that we haven't really landed on our opinion of. And a lot of times monitoring comes along with an aspect of funding that's required from doing like conservation banking or mitigation banking. A lot of times those also come with a conservation easement, and sometimes that's not very palpable. So we're thinking about, you know, potentially encouraging that sort of monitoring on this land to accommodate that if it does become a reality in the future. Another really important aspect of long-term monitoring is learning from our mistakes and managing how the project is implemented in the different phases. Right? If one thing doesn't work, and we know from our first 2 years of monitoring that that system just failed miserably, we're not going to do it again. So we're going to learn from these monitoring. And then also I see it as a really great educational potential as well. You know, there's a lot of opportunities out there to present ideas of what we've learned and what we've failed at and what we've succeeded at to provide, you know, insight for other people that are interested in doing similar projects, not only here, but elsewhere. And I'll keep moving along here. We're almost there. And I think we're going to come down to the concept timeline. That's our timeline. It's phased out, right? We got to initiate the project. We have to establish our goals and objectives and find our funding. We have to make sure the public is involved in this so we know what we don't know. And then we have to decide, you know, what we're going to go forward with. We're going to establish what our baseline conditions are, and then we're going to develop the concept design. After that, project implementation. And we're thinking infrastructure, irrigation infrastructure, Little Creek restoration, since it's a small segment, taking what we learn, move to Big Creek, break it into 3 segments and move on from there. And hopefully by the time we get done in the next 4 or 5 or so years, we've got something that we can look back on and monitor for years to come and hopefully provide a success story in the end. That's all I got, guys. Any questions? I saw some pop up in the chat there. I suppose there's probably some.
Yeah, so there was one from Clayton Nalder. He said I worked in the Lemhi 20 plus years ago. One of the struggles when going to more efficient irrigation systems was that because the drainage was so over allocated with water rights, it was difficult to keep the saved water in the stream channel downstream. Has there been discussions with the state on how to do this?
There's not been discussions with the state. No. And the water budget and understanding the water rights that we have out there right now are going to illuminate those. I think that we probably have such a short watershed and probably such a less complex irrigation allocation system when compared to the Lemhi, that's not going to be as big of a concern, but certainly is something that will need to be illuminated through the baseline site assessment.
Yeah, as we go through this project, that's one of my major concerns is having enough water and making sure my water rights are protected and allocated correctly. So in this whole project, that's one of my major concerns.
More questions? Yes.
So how does it work when a system is basically a flood irrigation? So it's a use and reuse system, and you go to more efficient use. How does that affect the people who are still expecting the return flows for their water?
That's a great question. And one of the biggest focus of the irrigation infrastructure is to do a conservation project there and to maintain as much as possible no return flow back to the creeks. And that's a big deal, right? And it dovetails into what you're talking about. Mainline installation is what gives us the opportunity to make sure that downstream water users have the water delivered to them wherever their diversion may be.
And we'll still be responsible for transporting water through our property to get to other property end users that have the water rights for that water. So, and that'll be a major part of this project. So if other people downstream from us do not want to tie into our project, then we'll have to either pipe or leave our ditches open to make sure they're still getting their water.
Very important and a superior priority of the project. Absolutely.
Yeah, that'd be the #1 priority because we have to take care of our downstream users before we can do anything.
Legally.
Yes. Yep.
Kind of a segue off of that. Do you intend on doing the geo-survey before or after you start with infrastructure? Because if you're changing the resupply for groundwater, you might be affecting a lot of wells before really seeing the other advantage of that.
You mind if I?
You're switching from irrigation, your recharge for groundwater is gonna be different than sprinkler, because you're gonna lose more through evaporation.
Yeah, so I think,
Sorry, can you repeat the question?
yeah, absolutely. The question is, would the geotechnical investigation be done prior to or after the infrastructure is implemented, specifically concerning like what it does to the groundwater recharge? And my recommendation with that would be to have a geotechnical investigation beforehand so we can understand what the groundwater's at. And so we can understand what materials we have. It's going to affect the stream restoration when we start excavating. We want to know, what we're going to find. But also, oftentimes on projects like these, we'll do some type of groundwater monitoring throughout the project, and then those monitoring wells remain in place afterwards. And it's basically just a pipe in the ground where you can check that every so often to see what that groundwater level is doing, because that would be really important, especially as we're phasing the project. We want to understand what our changes to both the irrigation and the stream restoration are doing to the groundwater.
And to speak to groundwater recharge, I know that's an important aspect up here. And at this point right now, with all of the irrigation that's been happening, the flood irrigation over the years, there's been kind of a change to the natural groundwater recharge that would have happened. And I don't have, the citations to prove or anything like that, but I have done a bit of research and understand that when riparian corridors are expanded and the water is slowed down in these riverine systems, you get a lot more groundwater recharge.
Yeah.
And so we expect that to actually improve the recharge and slow that water down so it doesn't just flush out, creating more erosion. And great questions. Thanks a lot for letting us come here today, guys, and present this idea to you. And we look forward to hearing from you. And no question's a bad question. Even the hard ones are all welcome. So I really want to reach out and thank the Oberdorf family. And these guys don't have to do this project. This is on their willingness to do something right on the landscape. And it's a brainchild of theirs, and we're just here to try to facilitate that. And also thanks to Tim to help provide some technical insight. And the question to the Zoom group was, what is the potential energy gain from a small hydro system in the mainline pipe when we're looking at 150 foot of drop from where the source water would come onto the property, when considering small hydro turbine applications? And the easy answer to that is I don't know, but it could be substantial. It could be substantial. Yeah. Yeah.
And you're not losing anything.
Yep.
And you're going to agree. Does that require further licensing?
That's a great question. Because it would go back on the system. I imagine there would be surplus. Corey, Gary,
Good.
you're good. Okay. Anyone else? Thanks, guys. Sure do appreciate it.